Welcome to SAT 021. The topic of this lesson is parallel and perpendicular lines. Different lines in the same plane that never cross each other are said to be parallel. So we have the XY plane, and we have two lines. And two non-vertical lines are parallel if they have the same slope but distinct y-intercept. So the equation of the top line is y equals half of x plus 4. The equation of the bottom line is y equals half of x minus 2. And we can see they have the same slope, 1/2, the number in front of the variable x, but they have different y-intercept. One is 4 and one is -2. And two lines have the same slope and the same y-intercept. They coincide. Okay, they are exactly the same line. And then any two vertical lines are parallel no matter what. Two lines in a plane that intersect at a right angle or 90 degrees are said to be perpendicular. Okay, so we have two lines and they intersect at a right angle. Now, two lines are perpendicular to one another in a coordinate plane if and only if the product of their slope is -1. Okay, so let's double check these two lines to see if they are perpendicular or not. The slope of the first line is 1/2. The slope of the second line is -2. And the product of 1/2 and -2 is -1. So these two lines are perpendicular, because the product of the slope of them is -1. And horizontal lines and the vertical lines are perpendicular no matter what. Now, let's have a practice question. Which line that one of the following equations represent is parallel to the graph of the equation 3x minus 2y equals 4? Okay, so the equation given is 3x minus 2y equals 4. The slope-intercept form is the form that the slope is very visual. Okay, so we can see the slope right away. So how about we change the form to slope-intercept form? And parallel lines, basically we need to check the slope in front of x. Okay, so to change from 3x minus 2y equals 4, we need to move x to the other side, and then we divide -2 to change the coefficient of y to 1, and we simplify it, and we get y equals 3 over 2x minus 2. So that tells us the slope of the given line is 3/2, and the y-intercept is -2. Okay, so now for a, okay, we need to do the same thing. So for y, and then the slope of a is -3/2. Different sign, not true, not correct. For b, do the same thing. So for y, and then the slope of b is -2/3. Not even close. Let's check c. So for y, for c, and the slope of c is +3/2. Okay, so that's exactly the same as the given line. So C should be the correct answer. But to make sure, let's still check D as well. Okay, so that's D. We solve for y and find the slope of the line in D that's -2/3, which is different from the slope of the line given. Okay, so the correct answer should be C. And when we look at the forms of C and the given line from the question, they have exactly the same slope, but different, distinct y-intercept. Okay, C. Okay, so now let's look at another practice question. Line J crosses the y-axis at 0,9 and is perpendicular to the line with the equation -3x plus 2y equals 7. If the point 9k is on line J, find the value of k. Okay, remember, we're looking at two lines perpendicular to each other. So the slope, the product of their slope must be -1. Okay, so now convert the given line to slope-intercept form, still by solving for y. Move x to the other side, then divide out the coefficient of y. So the slope of the given line is 3/2. Since the product of the slopes is -1, then the slope of the required line is -2/3. Okay, now with the slope found and then the y-intercept given from the question, so we can write the line in slope-intercept form. Y equals -2/3 x plus 9. And we know that 9k is on the line. That means the x-coordinate of that point is given. Plug in x equals 9 to the equation, and then y is k, so k equals 3 at the end. That's all for this lesson. Thank you for watching. Goodbye.